Good afternoon. Today we are going to finish chapter 1. It's talking about how to solve the method of solving and proving. I remember that in the previous lecture we talked about direct method, right? We say direct method is what? How many ways we have, how many methods do we have for solving? We see that bring a clean one. Okay. So how many methods do we have for proving a theorem? Two methods, right? Two methods. Direct and indirect. And we see that they are proof. We can prove it by direct or indirect, right? Indirect. Okay. And you see direct is P implies Q. We are not going to change anything. We start with P and then we will get Q, right? How about indirect? We say we have two methods. Contrapositive and contradiction. Okay? So now today we are going to mention both of them. We try to cover both of them. Contradiction, you have P then Q, so contrapositive, sorry. You say is equivalent to negation Q, negation P. I think we say that many times. So to solve that one, we are going to solve the example to understand. So here we have a contraposition, you can see. And as well we have what? We have an example. So here's the example. Proof. How to prove, how to understand. First, you should understand the question, the theorem. Then distinguish or recognize which one is P, which one is Q, and which is between them. Then later you can prove it. So now we have what? We have proof that, okay, we are going to prove that if n is an integer and 3n is odd. So now I have n integer, but the important thing here is P, n is what? 3n plus 2 is odd. Then show that Q, n is odd. Understood here? So it's important to select which one is P, which one is Q. So now we have 3n plus 2. You can see 3n plus 2 times n for all n in integer number. Now, 3n plus 2 is odd. Show me on n is odd. That's the question. You can try at home the direct method. You will see you will not get a good things, or maybe you will be tired till you get the result. Understood? So that's why we are going to use contrapositive. We say this is P, then Q. We are going to use negation Q, then negation P. Okay. So tell me negation Q is what? We say n is not odd. Am I right? Then I want to show that, we want to show that 3n plus 2 is not odd. Am I right? N is not odd mean what? N is what? We have a number. If it's not odd, it should be what? Even. Then I want to show that what? 3n plus 2 is even. Am I right? Now this one is easier for me. So I say n is even means what? We say that if number is even means that there exists a k from the integers generally such that n equal to what? 2k. Am I right? Because even. Okay. So tell me about 3n plus 2 equal to what? Can I write that one like a 2k plus 2 or not? Yes, because we say n is even, okay? Take care. So we say what? We say is equal to 3n plus 2k. Good. Now I know I will get 6k plus 2, and I'm going to take 2 as a common, then I will get 3k plus 1. Am I right? Hello? Good. Now, And I can write down, I know, k is from integer. 3k, of course, will be in integer. 3k plus 1 also is what? In integer, right? If you add, if you multiply by any integer, you'll get the integer. Am I right? Good. So that's why I can write that, write this like that, 2l. Am I right? So means 3n plus 2 is equal to 2l, which means that is what is even. Understood? So we start from the left side, we go to right side, which we used contrapositive. So when you get a true, when you get the result, means that the theorem itself is true or correct. That's how you prove. Any question? Yes. Nothing, but sometimes you cannot get the result. Try at home. For example, I'm coming to you. For example, you have 3n plus 2 is odd. Okay, yalla. 3n plus 2, 2k plus 1, right? Then you need 3n is equal to what? 2k minus 1, right? So you are going to say n is equal to what? 2k minus 2, 3. How do you know that one is even or odd? Understood? It's not clear, right? You cannot decide n is odd or not. It's not. That's why we cannot use the direct. Even I say try at home, but we did because he asked it. Yes, Kak. Actually, we have two types of the question. Thank you for your question. We have two types. One of them, I say use contrapositive to solve, to prove. That's the selected. Or some of them, I don't say anything. So when I don't say anything, you are free. When I say, you should use it. Depends on the question. Understood? Up to you. Free. Feel free. Direct, indirect, contradiction, contrapositive, whatever you like. But be sure that one of them is easier. One of them is easiest one.
I think the indirect is easy.
Which one? Indirect? Maybe. Depends. I don't say yes. Depends, because that's why we have three methods. Because depends on the question. Maybe that one indirect is easier, maybe direct is easier. Depends. For example, if I say n is odd, then show me n squared is odd. That one is easiest way. The method is direct method is easiest one. But if I say n squared is odd, show me n is odd, contrapositive is easiest one. Understood? Depends. Understood, Kaka? No more question? Good. So we have many examples here. I'm going to cover it. So he told you that start with the direct, here's the indirect, here's the contrapositive, and here's the direct, which we didn't get anything. That's why. Now, we have another one. Prove n equal to AB, then n like that. So n equal to AB, another theorem. Then show me n is what? A less than equal to square root of n, or b less than equal to square root of n. Look at the example and read that one. Positive integer, not for all of them. Understood? Maybe in your mind, you say if I have minus 1. So minus 1 cannot apply in this example. Why? Because you have a condition that said what? A and B are positive integer. Understood? Good. Now, A and B belongs to Z integer, Z positive. So you know these symbols, like n, is used for natural number. And that one is for integer number. Sometimes we say Z plus or Z minus, right? And of course, rational number is Q, irrational number is R, IR, and real number is like that. Sometimes we say positive real number, right? So these symbols for the sets, whole sets, universal sets. Okay. So here we are, n is equal to AB, then show me that one. You cannot decide directly, maybe. N equal to AB, so how I decide that one is less than that, you can see it's not easy, right? So I'm going to use the contrapositive. Say here's PQ. So I'm going to use negation Q to negation P. Yalla, show me negation Q is what? Directly I'm going to write. I say negation of A less than equal to N or B less than or equal to N, then negation of N equal to AB. Yalla, tell me. Negation of the left side is equal to what? You can translate it as what? A greater than N. Thank you, right? And or will change to what? And. And how about that one? Greater than N. Then, how about that one? Negation of here? Not equal. N not equal to AB. You are right. When you say not equal, you mean what? In your mind? What do you mean by not equal? No? Not equal to AB means what? Or? Am I right? That one is not equal to that one. Maybe greater, maybe smaller. Understood, dears? So when you say not equal, maybe that one or that one. Or. So, if I get one of them, means that I prove it, right? Because or between them. So, let me start with the first one. Yalla. A greater than N and at the same time B greater than square root of N. Okay, so how about multiplication? So now I start with the left side. Now I say multiplication between these two will be AB will be greater than N and M. Am I right, Jamaat? Hello? Wow. Good. Which means that AB greater than what? N. Did I get one of them?
Yes.
So it means that I got the result. If that one false, but that one true, I will get what? True. Al-Muhim what? The important thing is AB not N not equal to AB, right? Even greater or less. So I got the result by 2-3 steps. Most of the questions that we are going to solve in this, especially in the chapter 1, you need 3 or 4 steps, no more. Even in your quizzes, in your homeworks. 3 steps, 4 steps. Understood? Clear? Tamam? Question? No question. Good. So here we are, we use the contrapositive and we go that one. Okay. Example number 5, I'm going to leave it for you as a homework. But you cannot answer or you cannot understand example 5 without example 6. So kindly be with me to understand that one, then you can answer or solve example number 5. Understood? Yalla. Listen and analyze the theorem. Yalla. Prove that. Okay. For what? If n is an integer. Okay. Now n is integer. Good. With n is what? N between 10. What's your example number 6? Between and what? 15. Okay. And n is b square. Why I say n is equal to b square? Because which is perfect square. What do you mean by perfect square? Any number which we can write down like that. Am I right? Then that's all p. Then n is also perfect cube. What do you mean by perfect cube? Show me n is a to power 3. Let me say that. Or b to power 3, whatever you like. So now we have a given n is between, look, n is between 10 and 15, then show me that, okay, show me that an n is square, show me that this n is cube. Yalla, give me the number. Which number between 10 and 15 and is square? N is what? You know. N is integer. Do not forget about that. Yalla. 3 to power 2. So if n is equal to 3, 3 to power 2 is equal to what? 9. 9 is here, right? It's not inside. Yalla. Give me an integer number. There is no. Why? If you say 4, 4 square will be 16. It's outside, right? So I have a 1 square 1, 2 square 4, 3 square 9, 4 square 16. So between 10 and 15, we don't have anything, right? So means that I start with the false statement. We state a false proposition. Understood what I say? We don't have such thing like that. So we start with false. Even here is false or true. The result will be what? P implies Q. Let me do it for you, because actually even you don't know how to understand with the truth table, unfortunately. Yalla. If I have PQ, I have true, true, false, false, true, false, true, false. If I have P then Q, if that one true and true, I'll get false. So if here's false, if here's false, the other result, the other side is true or false, I'll get what? So the result of here is what? If the given is false, the Q is true or false, the result will be what? True. So means that this question at the beginning is wrong, it's not a question. If you insist to be the question, I say the result is true. Understood? So it means that you don't need to prove it. There's no way to prove it. Why? Because we start with the wrong thing. It's wrong. Then the result here is anything that I have. Is true or not, I don't care, because the result will be true. That's why you can see from here. You see what? He say the perfect square is false. That's why consequently the statement be proven is what? Is true for all integer n. So means that yes.
What if the square was true?
We should prove it. We should think about it or prove it. Understood? But here we think about it and we got nothing. When you got nothing, nothing true means that you don't need to prove it. Directly say it's true. Yes, God. Yes, I approve marker there. Okay.
Can you change the false to true and try to
How? How I change?
Like
I say between.
perfect square, for example, if it was true.
Okay.
And you solve it, or change the number, make it
Okay.
true.
If it's okay for you, I'm going to answer that one when we receive the counter example. Okay? Kindly remember me here today, طبعا. Here we have a counter example somewhere, written counter example. In here. Here I can answer you. Okay, dear? We are going to solve it, to prove it. We see is solvable or not. So I cannot answer you now because we need more things. Good. Did you understand, dears? Good. Do you have any question about example number 6? Kindly use the same strategy to answer example number 5. Now, Yalla, you passed the Cal 1 and Cal 2 and many things of the math. Tell me about the rational number. What's the definition of rational number? Rational means that Q. Definition of Q. Yes?
Doesn't like anything.
No. Yes, you are right. They are real number.
Like all numbers.
The definition. So how, for example, if I don't have a real number, I just have a natural number, integer number, then I'm going to define new state. It's called Q. Yalla.
It's whole number, not by a fraction.
Yes, exactly. It's a fraction. So Q number is fractions. Okay, like what? 1 over 2, 2 over 3, you are right. 1 over 2, 3 over 2. So generally define for me. Generally.
It's not a whole number.
No.
1
Is equal to A over 2. No, that is decimal. Is equal to A over B when A, B belong to integer number and B never be 0, right? Generally speaking. So this is the definition of rational number. Give me any number. For example, you say 3 over 2. 3 over 2. First, 2 is not equal to 0. Am I right? So that's the first condition. Then, I have 3 which belong to Z. 2 also belong to Z. So 3 over 2 is what? Is a rational number. Understood? We apply the definition. So this is the general case of the rational number. Do you have any question, dears? Hello? No question. Good. Now how we solve it? How we solve them? Kaka? What's the question? He said that if Alashi, prove that. Okay, I'm going to prove what? The sum of two rational numbers. So I have R and S. R and S belong to Q. Prove that S plus R or R plus S also belong to Q. You say what? Just kindly read the statement. We have prove that the sum of two rational numbers is rational. So it means that R and S belong to Q. Then show me the sum of them. R of S, R plus S is also Q. Can you do it for me? I say R belong to Q, right? So there exists A and B belong to integer number, B not equal to 0, such that, am I right? R equal to what? A over B. Am I right? Because R belong to Q. How about S? Also S belong to Q. So there exists C and D in the Z integer, D not equal to 0, such that, okay, S is equal to C over D. Do you have any comment? Because separately, they are belong to where? To Q. Yes?
You can also say C over B.
Yes, you can. You can say anything that you like. But generally, we should write it, okay? So, now I am going to prove it. R plus S is equal to what? A plus B, C over D. Am I right? Then I will get what? They?
AD plus E.
Am I right? That one not equal to 0 by given. And that one also not equal to 0, right? So multiplication between two non-zero is equal to what? Non-zero. So I'm going to rename it by n, which 100% is not 0. Am I right? Hello? Do you agree with me? Good. And A belong to Z. And also D belong to Z. How about multiplication? Two integer number. Give you integer? Yes, of course. Give you integer. Let us say alpha. How about that one? Beta. How about addition of two integer? Integer, right? So I'm going to write M. So now R plus S is equal to what? M over N. Am I right? M and N belong to integer number and N not equal to 0. Am I right? We prove it. So that's mean R plus S belong to Q. Do you have any question? It's easy, right? Just need to work. Kindly, at home, try one time or two times, try to solve these examples again and again. Because the questions is look like them or like them. Yes, Kaka. Okay. No. No, not about RS. Let me answer you. Not about that one. When you say 1 over 2 belong to Q, of course, 1 also belong to Q, 2 also belong to Q, 5 also belong to Q. You know why? Because here's the denominator. Right? Every natural number, every natural number, they are integer number. All natural and integer, they are rational number. Means that that's the set n, natural number, that's z, and the biggest one is rational. Of course, the large one is what? R. Understood? You got it, Kaka? Level off. So every integer is also automatically will be rational. Why? Because the denominator, I can put it 1 and satisfy the definition of the rational number. You got it, Kaka? Good. Let me see what we have. Yes, example 9 is very important. Later, in example 9, we are going to use it by conditions. So now I'm going to solve one of them, one part. Later, I'll leave the other for you. So kindly understand from here. We have what? N square is odd, then n square is odd, then n is odd. So we have n belong to integer number, n square is odd, then n is odd. Can you solve that one by direct? No. Why, Kaka? Why we cannot do it by direct? Yalla.
We first have to prove n.
No. Tell me why we cannot directly say n square is odd. Then I'll get n is odd. Why? Like what? What do you mean? Square? No square. No. So n square is odd means that 2k plus 1. Am I right? Yes. So n is what? Because I want to n. Do you have any guarantee to show you that one is odd?
We have 2 answers.
2, 3, could have many answers, right? We don't have a guarantee to tell you this formula is odd. Do you have? No. So that's why P then Q is not working, right? So I'm going to solve it by what? Yalla. We are going to solve it by what? Which method? Contrapositive. Okay, contrapositive. Yalla. How? I say n is even, then I want to show that n square is even. Am I right? Okay, n is even means what? There exists k belongs to k to z such that n equal to 2k. Okay, make it square. Am I right? Am I right? K is integer. K square, integer. 2 multiply per integer. So, you got it? So, it means that n square is even. Am I right? We solve it by indirect and we use the contrapositive. Do you have any question? Did you understand? What did we do? First, we tried the direct. It wasn't work. We used the next method, indirect, contrapositive, and it's worked. We solved. Do you have any question, dears? Clear everything? Good. Now, last or the other method is contrapositive. Yes, of course, contradiction. We use the contradiction. What's a contradiction? Look at me. Just 2 techniques, no more. Just listen to me. 2 things. Contradiction. We symbolize by that. Contradiction. We have P then Q. Look, I say I'm going to use P and negation Q, then I will get something false. False to what? False that P is true. So I say P true, and I say let that one also be true. Then I am going to get something which say P is false. P is false. طبعا, of course, now you have a headache because you don't know what I mean. Let me show you these symbols, this method. By example is easier. Look at here. First example. طبعا in your lecture note, there's something I passed. So kindly pass this example. We have something here, some example. I delete it, which is not easy to you, okay? Now I'm going to use this example.
So example 10 and 11.
Yep. Yes. Yes. 10 and 11 cancelled. Now we have 3. We need to show 3n plus 2 and n. We have what? 3n plus 2 is odd. Show me n is odd. Yalla. Do you remember we solved that one by contrapositive? Now we are going to solve it by contradiction to understand. Bashakaka? Just understand that example. You can answer the quizzes and tests. Also, of course, your homework, your assignments. How we solve? How is the way? We see that. We have P and negation Q. Am I right? So what was the negation Q? N is not odd, even, right? Then 3n plus, sorry. When n is even means what? There exists k in such that n equal to what? 2k, am I right? How about after that one? We have 3n plus 2. And he told us what? The given is say what? By given. Odd or even? He said is odd, am I right? Now I'm going to use negation Q to get a contradiction of the P. How? I say 3, 2k plus 2. Am I right? N is what? Like that. Then I'll get what? I will get 6k plus 2. Then I will get 3k plus 1. Am I right? Then I say I go 2L and I say this is contradiction. Why I say this is contradiction? Because we show that we start with a 3n and we got what? 2L, right? But by given, this is odd. We show that it's even, but it's even, but by given is odd. That's why contradiction. I'm going to repeat for you again. Kindly listen. We have 3n plus 2 odd, then n odd. I'm going to use contradiction. I say negation Q and using P will give me something which is false. How? I say negation Q is n odd, n even. Then I have a P. I say n is even means that n equal to 2k. And we have 3n plus 2 is odd. Then I'm going to use here, I say 3n plus 2. And instead of give me odd, if I put, I'll get what? Even. That's why contradiction. Did you understand? Dears? Hello? Okay. So everything is clear here. And that's all about the methods. we have only equivalent counterexample. Okay. Do you have any question about here? I think it's very hot, right? So let me turn on the AC maybe. Yalla. Proof equivalent. What do you mean by proof equivalent? Listen to me. We have one example. طبعا we have a biconditional here. Sorry. I told you I'm going to leave this one for you. He say what? He say what? We have what? If n is odd. What do you mean by if and only if? We say n is odd. Then n squared is odd. We solved that one in the previous lecture. Today we solved that n is odd, then n is odd. Now, you say what? N is odd, if and only if n is odd. Understood? N squared. So if you try to, during the exam, if you have such theorem like that, you need to show me both. You say if part n is odd, then n squared is odd. And only if part, so you prove that one. When you finish, you are going to solve the only if part. You say n squared is odd, then n is odd. Maybe that one solved by direct, maybe that one by contra positive. Up to you. The important thing is you should solve both cases. That one and that one. Understood, dears? Good. Now we have equivalent. What do you mean by equivalent? Look at here. We have three cases. Okay? Three cases. Here, two here. Then you should show here, two here. Then you should show here, two here. What do you mean by that? If you have three equivalents, P1, now I'm going to solve together that one. P1 to P2, then later show P2 to P3, and like a cyclic, then P3 to P1. You should show me that when we have an equivalent, three statements. Understood? 1, 2, 2, 2, 2, 3, 3, 2, 1. Okay. Can you solve P1 to P2? Yalla. There. Move. Yalla, together. Together. Yalla, silent. Silent. Yalla, P n is even, P1 to P3. To P2, sorry. N is even, n minus 1 odd. N is even, n minus 1 odd. Yalla, how we solve that one? How we solve? Direct? Let me try. N equal to 2k, right? There exists k belongs to integer numbers such that n equal to 2k. Okay. So I say n minus 1 equal to what? Why I say n minus 1? Because I want to show that is odd. Understood? Means that I want to show that n minus is equal to 2l plus 1. Am I right? Understood? Good. So how I show that one? Can I say that? Can I say that?
Yes.
We can, right? Plus 1 minus 1. So, and can I write that one like that? Hello? And we can write like that, right? Am I right? And n minus 1 equal to 2l plus 1. So I show that if n is even, n minus 1 odd. Yes? No. Just I bring it because plus 1 minus 1 equal to 0. We call in our pocket. We call in our pocket 2 balanced. Why? Because I need this formula. 2L plus 1. That's why. Understood? Good. Yes? No. Because you are speaking with your friends. Yep. Yep. Understood? Yalla. Quickly repeating. N minus 1 odd. No. N is even. N minus 1 odd. N is even يعني 2K. N minus 1 odd يعني 2L plus 1. So show me that one. If you have that one, show me that one. So I say because N is equal to 2K, then N minus 1 to both sides. Am I right? Then, because I need this formula, I'm going to minus 1 plus 1. Because that one will be 0. We add and subtract minus 1. Understood? Okay? Then, equal to 2K minus 2 plus 1. Because I know minus 1 equal to minus 2. Then it will be K minus 1 plus 1. Then it will be 2L plus 1. Means odd. Now, second statement, what we have? N minus 1 is odd. Show me P2 to P3. N squared is even. Understood, Jamaat? Hello? How we show that one? They بجوله. This is your test. Barwa, this is test. Yalla. Answer. Be here, please. Yalla. They? Yes?
The n minus 1 is equal to 2k minus 1. The second one is 2k squared. And we check that.
Yalla. N equal to? Tana, we want to show that, right? So N equal to what?
N equal to
2k plus 2. Am I right? Then N equal to what? 2k plus 1, right? And N squared equal to what? Oh, sorry. Yalla kakaran. Continue. So N squared equal to? Am I right? 4k 4. Tamam? First square, 2 multiply first by second, plus second square. Okay? Then N square equal to what? I can say is equal to 4, 2, sorry? You cannot divide by 4. You know why? Can you answer why? Students? No. Both sides will be 4, so the other side we should multiply it again. So you don't need to. So 4 exactly, x squared plus 2k plus 2. Sorry. Am I right? Yalla, and complete square and understood. We change to the formula to 2k. Why? Because we say that, look, we have that one as odd. We try to show that n squared is even to L. So we bring the other two here, we go that one. We make a square to both sides. We open the square, expanding. Then we go that one, we change it to that one. We took a 2 as a common because I want a 2L. then we rename that one as L. Why? Because I know 2 is multiply any integer will get integer, then that's why. Understood? So till here is 2 over 3. 2 of third the answer. Why? Because we show P1 to P2, and now we prove it P2 to P3. It remains what? P3 to P1. What's the P3 to P1? N squared is even, then N is even. Can you solve that one for me? There. By odd we did it. Tell me how we solved the even. Yallah. It's easy. They.
The same like example 1.
How we solve?
So both of them are not odd.
Yes, exactly. So how we solve them? By which way? Direct or indirect? Contrapositive. Okay, so negation of here, we say N is equal to 2K or 2L plus 1, right? Why? Why we say that? Jama'at? You know what? If you are be with me is better, because later you'll feel nothing. Because later you feel you are dizzy because you don't know why. But if you are listen to me, it will be easier for you, I think. Look, by contrapositive, so we say N is odd. We show that N squared is odd, and I think we did it. So N is odd means that 2K plus 1, right? Then N squared is equal to what? 2K plus 1 squared. And I will get what? 4K squared, 4K plus 1. Then I will get what? Am I right? Tamam? Did you understand what did I do? Hello? Did you understand? The question, let me show you. The question is like that. Okay? N squared, no, wait. N squared even, show me N is even. We cannot directly solve it. So we change it to the contrapositive. We say N is not even, then we are going to show that N squared is not even. N is not even means that N is odd. Then we want to show that that one is odd. You got it now? Okay. We say that some of the question does not mention. But if I mentioned, you should use it. If I don't mention it, how we know? That was a question. Use the direct. You cannot solve. Yalla, N square even. Show me N is even, right? The question was like that. Am I right? Yalla, use direction. Direct solve. N square is even means that N square is equal to 2K. Okay. So to show me N is even or odd, I'm going to take N, right? Square root of both sides. Am I right? Why? Then N is equal to square root of 2K. Can you tell me, is there any formula to give us if N is equal to square root of 2K is even? No. Right? Did you understand? You cannot solve by direct. If I solved by direct method, I will get N equal to square root of 2K, which is not helpful. Not give you any clue, any things. That's why I say I am not going to use the direct. I'm going to use the as kaka, let's say, contrapositive. And we use it and we got it. Understood kaka? Okay. Now that's all about equivalent. Then I'm going to stop here for 10 minutes. It's 9 minutes actually. So come back at 9 minutes, after 9 minutes. Welcome back again. Welcome back again. We are recording. Kind enough. Stop. So here we are. We see that we have a counter example. And I told you, if you counter example, these deals with one example that make your theorem false. For example, if you can give me an example that if n is odd, even, then n minus 1 is odd. Give me one example. This theorem is not right. I'm going to give you PhD directly. Yalla day. Give me one example for each n belongs to integer number. N is odd. Sorry, n is even. Then give me one example which is not true. N is even, but n minus 1 is not odd. Yalla. Huh? Give me a number. Which number? Integer. Kindly. Integer number. Yalla. Hey, think about it. Yes, 1. 1 is even? No. 2 is even, right? So 2 minus 1? Odd. Still odd. Give me one number which satisfies this condition, but here is false. Yalla. Okay. Silent. Kindly not hands up if you have. Yeah. 5 is not even. I say give me numbers even. 5 is not even. Even kaka. Kindly. I know you like PhD. I know. That's why you are in a hurry. Just be patient. Understand, then answer. This time, if you answer, if your answer is not correct, I'm gonna minus 1. Okay? So kindly wait. Understand, then answer. Give me a number from the integers. Any numbers. One number, no more. Such that this number is even. When you make it minus, give me not odd. That one is theorem. My question is what? Give me a counter example. N is even, n minus 1 is even. Yalla day. Did you understand? Yes. Integer number. 1, 2, 3, 4, minus 1, minus 2, that's integer. Yes. Minus 2, yalla. Minus 2 is even, he's right. Then minus 2, minus 1 will give us minus 3. Unfortunately, is odd. Unfortunately. Yes. So you cannot find it because a theorem. Don't worry, because a theorem you cannot find it. Because it's a theorem means that the theorem, when you say something is theorem, there is no counter example on it. Because prove it. We prove it. So there is no way to find the counter example. But for example, if I say n is odd and n minus 5 is odd, I don't know. Maybe you find such example which is not true, which my theorem is not true. So this is called a counter example. Look at here. To understand. Every point, positive integer, listen, this is not true. Maybe it's false or it's not theorem. He say what? Every positive integer is the sum of the square of two integers. Is false or true? He says false. Give me the counter example. This is false. Every positive integer. So, for each n in positive integer. Okay. What else? Thus, is the sum of squares of two integers. So, n is equal to a square plus b square, where a and b also belong to integer number. Okay? So we have two integer number. If we make it square, I will get what? Or sorry, n is equal to the square of them. Is that right or not? He says false. Give me the example. Give me one example, Dave. 2? 2? Yalla. 2 is equal to what? Can I say? Huh? 1 square plus 1 square. So 2 is not good example. Yes, AUB is integer number. They should be integer number. They should be 0. 0 equal to what? No. 0 not belongs to integer numbers. Positive integer numbers. Okay? So you can say 0 plus 0. They are right. So this example is not good. Yalla. Give me another example. 9 is equal to what? They? Huh? I think I got the example wrong. So just let me see. No. So you say give it. Let me read again. Every positive integer is the sum of the square of two false. Okay. So the statement is not true. Wait. Every integer number. Let me write the statement. Sorry. If I have a 3 is equal to what? Prime numbers, yeah? So 3 is equal to what? Yalla. Equal to what? 3. 0 is not belongs to here. Okay. 0 to what?
Okay, not odd numbers cannot be equal to odd. Even numbers.
No, my question is what? If I have 3, is 3 equal to sum of 2 positive? No. So we cannot bring anything. So 3 is what? Is counter example. Understood?
Okay, but you can say that for any odd number as well.
Yes, I say just give me one example. I don't say 5 is wrong. 5 as well is true, but I need 1. So 5 equal to something like that? No. Right? 1 plus what? 2. So 5 is not good. 5 is not example. 5 is not a counter example. Why? Because 5 is equal to 1 square, 2 square, and satisfy the condition. I say bring one of them, which is not true. Why I say bring one of them is not true? Maybe you confused. Because sometimes I say this example good, that one is not good. Why? Yes.
You need one example to prove the whole.
Why? Because we see for all positive integer, right? We say for all, and all of them means that 1, 2, 3, 4, 5 till the end, they are like that. I say bring one of them which is not like that. Understood? Give me one example which is not like that. Yalla. 7 is good. If I put 0, nabe. 1, 3 is working. 2, no. So I can only bring 7. I say n let n be 7, then n not equal to any square numbers. Tamam. You can bring 3, but 5 is not good. Careful, because 5 is equal. I say for all, means that there is no number to pass. But you bring 5, 3, and such number like that. Understood, dears? Why 5 is not? Why 7 is yes? Good. That's a counter example. If there's a theorem, you cannot bring it. If there's no theorem, of course, you will just bring one of them. Yalla. We have a mistake in proof. What do you mean by that, mistake in proof? Look at here, Kaka. Look. Let A be, you saw that one in the social media many times, kindly, and so for like a joke. A is equal to B, let be that one, okay? I say let A be B, okay? Now I'm going to multiply that one by A. I'll get what, Jamaat? Am I right? Now I'm going to subtract by B squared. I'll get what? Clear? Now, this is the difference between two squares. Am I right? And I'm going to take a B as a common. Am I right? Hello? Clear? Now, we divide by A minus B. Both sides. I'll get what? Am I right? But by given, we say A is equal to B. I can say by given A equal to B. So substitute it here. I'll get what? Change one of them. A plus A equal to A. Am I right? Because A, B are equal. So instead of this B, I'm going to put A. Or you can say B, B, B. So 2A equal to A. Clear? Divide by A. 2 equal to 1. Where's the mistake? Yalla. Day. Today 1 equal to 2. Yalla. Why? Where's the mistake? Everything is clear. A equal to B. Am I right? As algebraic, everything is clear. A is equal to A, B. A square, we multiply just by A. So A square, AB. We subtract, it's okay, equality, I can do it. We subtract by B minus B squared. We did both sides. That one is difference between two squares. There is no way. A plus B, A minus B. That one, B is common. Of course, we took a factor. Here we are. Then we divide by A minus B. Why not? Then we came to that one, and we got that one. Yes, one by one. Wait, last one. Yalla. Where's the mistake? Why 2 is equal to 1? Yes?
Because we need the proof to wrong answer.
Give me the mistake.
When you divide A by both sides, in that case, A would be 0, and you can't divide it by 0.
جزء ما قلتوا لما قلتوا أي إنسان هي كانت لا
I divide them كله. So where's the
أي إنسان بأي آخر أو السر ولا بيجوا السر ولا يبدأ أي إنسان بأي
Where?
لا سر فوق هذا شيء لا شيء لا سر
No, Kaka, no. What else? What else? كامل ستيبك كامل غلطة. حزي ستيبك أنا نوسم ياك دقة. Wait. وأنا بوي ليك بقي. أما يك 2 3 4 5 6 7 8. Yeah. 6. Wait, Kaka. Come back to you. Wait. يلا. So, why? Well, there is no wrong. A plus A is not equal to A. The same. Yeah, come back to you. In that case, yes. But here's who say A is equal to 0. Yes?
Divide 0 by 0?
No.
Because A, no.
Yes. You answered, actually you answered. There comes out to but I passed you. Mistake
A minus B is 0.
Yeah, exactly. We divide as a logic we have a problem. As what do you say? As algebraic there is no mistake. Understood? But as a logic we divide by 0 because we say A equal to B. So A minus B equal to what? 0. So we go 0. We divide both sides by 0. That's why we did a mistake. Thank you. And also you say IB 0. We divide by A 0. So it's not the same. Understood? So the mistake is here. Sometimes is what? Is the logic things. That's why logic is important. As a, what do you say? As a steps, the same. Everything is good. It's perfect. But as a division of the 0, there's a problem. We cannot. So that's why we mentioned here. So this is the mistake that we cannot do it. And forget about the example 17 and 18. And we stop here. If you don't have any question, I'm gonna stop your